Howdy, this is Tristan, and what I will go over is a brief overview of how we put together Hydra configurations to get a Monty experiment running. Let me orient you to our workspace here and what's going to happen. Over here on the right, these will be just reference materials so I can put together the configuration. We're going to do configuration the hard way. It will just be one big flat configuration so you can see how everything comes together in Hydra. And then the main workspace here will be here on the left. So let's get started. As a first place, we have Monty set up in a configuration. I'm going to go to experiments folder. And here in experiments folder, you can see a bunch of experiments already. I'm going to add a new file called my experiment YAML, and this will be my experiment. Straightforward. All right, let's get started. The experiment that I'm going to run is going to be the Monty supervised object pre-training experiment. So we set that as a target, and then everything else will go inside the config for this experiment. To get started, the first we're going to let's see, do train, do eval. So we're going to say that we want to do train to be true, and we want do eval to be false. So we will train, we will not evaluate. This, by the way, will mirror the configuration from the tutorial for running your first experiment. So it will be just a very straightforward, short pre-training run. So do eval, do train. Next step will be show sensor output. Will be false. We don't need to visualize anything. We're going to have max train steps 1. Again, this is just a quick demo, so we wanted to finish quickly. We can leave max eval steps, can really be anything because we will not be doing eval. Next step will be max total steps. Also will be short-circuited, but we're not going to run into this limit because we have tiny amount of max train steps. And then we have train epochs. We want to have 1 train epoch. Again, we're just doing short training. Eval epochs, we can take the defaults, they don't matter because we are not doing evals. And model name or path that we will use. We are not loading anything because we are training. We are not loading any pre-trained models, so there will be no model name or path. Min LMs match we will leave as the default. We will leave the standard seed in place, and then supervised LM IDs, we're going to supervise all of the learning modules. Again, this is a pre-training setting. So that is the main bit of the configuration for the experiment. Now let's configure everything that goes inside there. So next up will be logging. So logging configuration is nested. Let's provide it just before, so we don't forget, let's provide it a run name. The run name will be my experiment. And next, for logging, we are going to say that we want the Monty log level to be detailed. We will specify 3 Monty handlers that we want to add. We want these are Monty logging handlers, so we want the basic CSV stats that will generate CSV stats, generate JSON, and then reproduce episode handler. I'm pretty sure we don't need this one, so let's just do these 2. 1DB handlers, in case you want to send data to 1DB. We don't want to do that, so we will set them as being empty. And then we want the Python log level to be info. Python log to file. We do want to log to the file. We also want to log to standard error. And the output directory, we will go with the default, which was based on user expanded path for Monty logs, projects Monty runs. Um, we are not resuming in 1db run, so that is false. We will say we want to use these, but 1db ID, we can generate it, but we're not gonna be needing it. This is a debugging group, but if we were to run 1db, and we are not logging, we're not gonna log in parallel. Again, 1db settings will not take place because we don't have 1db handlers activated. Okay, and that is it for logging. Next, let us configure Monty itself. So, Monty itself, which Monty class are we going to use? We are going to use Monty for graph matching, which is our state-of-the-art Monty class. Let's configure the let's do Monty arguments next. So Monty args, which will be passed to this Monty class. So number of exploratory steps will be 1,000. Minimum eval steps will be 3. Minimum train steps will be 3. Max total steps will be 2,500. So these are the Monty args. That are the defaults that we pass to that class. Next up, I think that's it for Monty args. Let me just double check. Yeah. All right. Next up, so notice these are here for the experiment, and these here are for Monty itself. All right. So that's Monty class and Monty args. Next up, let's configure the motor system. So Monty, so the motor system. So it's motor system config. And the motor system config will have a motor system class, and that's the motor system, and it will have motor system args. And in motor system args, we want a policy. We're going to use the informed policy in this case, and we want to pass in some policy arguments, policy args. The action sampler that we will use is a constant action sampler, and that action sampler takes a rotation degrees as an argument, so we're gonna give it 5 degrees. And the policy args also need to know what agent ID the policy is for, and so we're using the agent ID, agent IZ0. This will turn in code, will instantiate an agent ID0 identifier for the policy. Okay. The other policy args that we will include is there is no file name that we are reading from if there are any pre-train actions type of things. Good view percentage, we want 0.5. Desired object distance 0.3. This is again for the informed policy parameters. We do not want to use goal state driven actions. Switch frequency will be 1. Min percentage on object 0 to 5. And then the other thing, and then one more thing we need to specify. So that's enough for the policy arguments. One more thing we need to specify for the action sampler class here is the action space, and so these are the actions that it chooses from. So actions. So the policy sampler, this constant sampler of actions, if we tell it to sample for random action, it will choose from this list of actions. So we give it the classes. We give it a lookup action, look down, turn left, turn right, set agent pose, set sensor rotations. Okay, so with this we have our action sampler class and with its arguments. We have our policy class with its policy arguments, and then we have motor system with motor system arguments. Let me just make sure that there's nothing else that I need to do for the motor system. No, that configures the motor. That completes the motor system configuration. All right. So next over, let's configure our learning modules. Learning module configs. And for learning modules, we're just going to have a single learning module. We're going to use the displacement graph learning module, and the arguments that we're going to give it is match attribute displacement, and k is equal to 5. Next up, we're going to configure sensor module configs. And we're going to have two sensor modules, one that will be hooked up to displacement graph feeding it information, and the other one will be a experimental probe so that we can look at what's going on in case we want to. So sensor module 0 will be the standard habitat sensor module, because we're using habitat for our experiments here. Sensor module arguments, we're going to give this the ID of patch, and then the features we want this sensor module to, we're configuring again the habitat sensor module, and the features we want the habitat sensor module to include are this list of features. So this is these are the morphological features that we wanted to send to the learning module, and these are the non-morphological features that we wanted to send it to the learning module. And we do not want to save raw observations. Sorry, we do want to save raw observations. Okay. And so that's the sensor. That's the first sensor module, the 0th sensor module. Next up, we'll do sensor module 1. And for this one, we're going to use the probe sensor module. Again, this is our experimental probe, so we can visualize things if we need to. We're going to pass in sensor module arguments, and the only arguments it takes is the identifier, which is the viewfinder, which is our kind of the name for when we want to look at an object that a sensor module is seeing. And then we also have save raw observations to true. And this concludes the sensor module configuration. Okay. The other bits of Monty so if you remember, we're still up here, we're still inside Monty. We config Monty. We configured Monty arguments. We configured motor system config, learning module config, sensor module config. There are a few more things we need to configure Monty with. And so this is how to set up the network between the sensor modules. How are these sensor modules, learning modules connected? So SM to agent dictionary. And we have the patch sensor module, which is the one that we created here. Sensor module patch. So sensor module patch corresponds to agent ID. The data from that corresponds to agent ID 0, and then viewfinder also agent ID 0. And then SM to LM matrix, sensor module to learning module matrix. And then LM to LM matrix doesn't have one. We only have one learning module, and then there is no voting happening in this. Okay? And so this completes our Monty configuration. Let's minimize these guys so they're out of the way. So that's Monty. What we need to configure next is, let me just review my reference material here. So we've configured the experiment, we've configured logging, we've configured Monty. Logging is part of the experiment, Monty inside of the experiment. Next we need to do is configure the environment. And so the environment will be, one second, environment. Okay, there we go. So environment will be configured in environment interface config. All right, and so the environment initialization init function will be instantiating the habitat environment, and then environment init args. So the arguments to this habitat environment are, let me see. It's going to, the agents that it's going to get is going to be agent type will be multi-sensor agent. That's what we're going to give it. And then the objects that we will put in our environment. In this case, we're just going to do a these are predefined objects. So there's in habitat, there's a cone solid object. We're gonna place it at this position. We're gonna tell this scene ID is null, seed 42, and then the data path is to retrieve object from habitat objects YCB from the YCB habitat object dataset. Okay. And then the other thing is we have agents, but we also need to provide, we have agent type, but we need agent args that we need to provide here to instantiate the agent. And agents patch and viewfinder. Okay, cool. And so the agent ID is going to be agent ID 0. Sensor IDs, there will be patch and viewfinder. And then the height of this agent will be at 0. We're essentially positioning this agent inside the habitat simulator now. Then resolutions correspond to the two sensors, so there will be so they both have 64 by 64 resolution. Positions, and then rotations. This is where we essentially set up these sensors. Like this agent has these sensors. And the agent is at this height, this is the agent positions, but these are the resolutions of the sensors, the positions of the sensors relative to the agent, rotations of the sensors relative to the agent. Semantics, false, false, and then zooms. And then these are the zoom levels for the sensors. Okay, this is all very habitat specific. So again, we are starting habitat environment from simulators habitat, and so this configurations is for habitat agents, and those have a specific configuration. Let me make sure that okay, cool, it was just a suggestion. Cool. So we have agents, we have agent type, agent args. Excellent. And so and that's it. So we have a habitat environment, and it's going to be configured with these agents, which are connected to these sensors. This environment has these objects. The scene, this entire scene is just, we're not going to give it an ID. We have a seed, and we have where the data for any objects that we define here comes from. Excellent. I believe that will, let me just double check. Oh, okay. And then one more thing we need to specify about in our environment is the transform. So what transforms, so once we receive observations from the environment, what transforms are we going to run before we hand them over to Monty? So one first transform that we're going to run will be missing to max depth. This thing has gonna have agent ID 0, and notice this agent ID is the same as the agent ID from the agent. And then the max depth will be 1. So if depth is missing, we're going to set it to 1. The other thing we're going to do is we're going to convert basically screen pixel data with depth data on top of it. So it's RGBD, red, blue, green, depth. And we're going to convert it into 3D locations. So that's what this transform does. Again, the same it works on observations coming from the same agent ID. It works on the sensors from that agent, and then this transform needs to know what resolutions it's working with, so we're just feeding it, we're just telling it that these are the resolutions that we set for the agent. We'll do this in world coordinates. Again, we have to pass in the zoom information, same one from above, and we want to get all points, and we want to use semantic sensor false. Alrighty, and then we also need to, we're not gonna give it any specific RNG. This is an artifact, I wouldn't worry about it. So environment interface config. This should complete our environment interface configuration. Let me just double check my references. So we have, let me just see, patch and view, habitat. Okay, so we have our environment init function, we have our environment args, and we have our transform. And we have our RNG for the environment. Okay, excellent. The reason this is RNG null is because we need to instantiate habitat with an RNG, and our current code will first instantiate habitat environment and then later on pass it an RNG. So this is just how we have things currently. This will be changed in the future. Okay, that should configure the environment interface configuration. Let me just make sure I put everything in the right place. Environment init function, environment init args, and then transform and RNG are at this top level. Okay, excellent. So now environment is configured. We're almost there. The remaining bit we have to configure is our, we said we're not doing eval, so we don't have to configure eval any farther, but we do have to configure how we're going to interface with the environment during training. So train environment interface class, and this will be environment interface per object, and then train environment interface args, and what we're gonna pass to that. Okay, so 1 second, let me once again consult. So the per object, so parent, we're not going to provide any parent to child mapping in this instance. And then, okay. And then the other thing we need to give it is what object names, what objects we want to populate the environment with. We're going to do a mug, object init sampler. And we want to use the predefined object initializer. Okay. And that should be a working configuration. So we have, let me just reduce it so it's easier to see. Okay, so we have our Monty supervised pre-training experiment. We have a configuration, high-level configuration for the experiment here. Then we have logging, Monty, our environment setup, and then how is our training going to interface with the environment. So for logging, we specified our run name, and then what Monty log level, what Monty handlers we want to do. These are like data telemetry level and handlers. And then this is your kind of standard logging. Is going to be info, and we're going to log to a file and to a standard error. That's where we're going to do it at. 1db is settings are ignored because we didn't specify any 1db handlers. Then we configure Monty. Monty configurations consists of this. And so we have our Monty class, which we're going to give it some arguments. We also need to configure our motor system, our learning module configuration, our sensor module configurations. And then we need to define how the network of agents to sensor modules to learning modules looks like. So for Monty args, here's the arguments that we passed in. For motor configuration, we need to specify motor system class and motor system args, which takes a policy and policy arguments, and then policies also take action samplers and action arguments like so. And then we have learning module configurations. In this case, we specified learning module class learning module args. I think I'm missing something here. Let me just double check that this is set up, this learning module configuration is set up correctly. Okay, yeah, I made a mistake here. Yeah, learning module configs is a dictionary. So this is our learning module 0, and this is class and arguments. Okay, this is the correction here. And then sensor module configuration, similarly, we have sensor module 0 and sensor module 1. And for this one, we have actual sensor module, its ID, and what features we want to pass to the learning module. And then we have our probe that we use for like visualizations and other things. So that's sensor module configs. Mapping between sensor modules and agents, sensor modules and learning modules, and then learning modules to learning modules and learning modules and voting, not applicable in this case. Then we have our environment configuration, where we have our environment we're going to stand up, which is habitat, and then what arguments we're going to pass to that, and then the transforms that we want to do before we pass the observations from the environment to Monty. And then this is just an artifact of how our code currently is. Just put RNG null here, but don't worry about it for now, any further. And then inside, this is habitat specific now. We need to specify what agents we have, what objects, scene ID, and the data path where habitat should be getting its objects from. And then this is the list of transforms that we want to apply to those observations. And then lastly, how the training is going to interact with the environment. So environment interface per object, and we're just gonna present a mug, and we use the predefined object initializer. And with that, we have our my experiment Monty configuration the hard way. And over here, we should be able to now, from top level, do run parallel experiment equals. Actually, just run, not run parallel. Experiment equals my experiment. The reason this works, my experiment equals my experiment, is because inside the conf experiment folder, we created a file called my experiment. And so that's how that mapping goes. If we were to create it, if my experiment was inside tutorial, then I would have to do experiment equals tutorial my experiment. But because I put it at top level, it should be here. All right, here goes nothing. Oh no, what did I do? Key error, Monty config. Let's see. Oh, I called it Monty. It's Monty config. I think that should fix it. Let's run it again. And there we go. There is our training happening. It doesn't do anything interesting because we just wanted to demonstrate the configuration and things running, but it's done running and it did the thing. This concludes the demonstration.